and get going. So welcome to Python. And really, if you've done no type of coding previously, like we said, it's the best place to begin coding and to kind of get an idea of what this whole like coding thing is. A lot of the things that you do in the Python coding language apply to all kinds of languages. It's the same basic principles at the deep level, and then it's just different ways of typing it out. If you go from like Python to a different language like C, Ruby, Java, it's all the same basic principles, and that's what we'll talk about in this class, just using Python to get going. So what this class will be, we'll do a couple sections of this class. And what it kind of is it's a little bit of a language class. Python is a language, not the same as like English and French, but it's a coding language. So we'll have to pick up on like the vocab and the ways of like writing the sentences in Python, that kind of idea. The second thing it kind of is it's a bit of a logic and math class. All you really need to do anything programmatic wise, it's just logic and math to kind of run functions, take data, do some manipulations to it, and do all that kind of stuff. And then the last thing it is it's also a bit of a creativity class. We'll find that it takes a lot of creativity to actually solve the problems that we'll look at. You can solve almost any of the problems that we look at in at least a dozen ways. So it's not like this is like hidebound and you have to know exactly the one way to solve one problem. You have a lot of ways you can do it, so you won't be too limited. It hopefully won't be too frustrating. And it's kind of open that way and how you want to solve things and what tools you know to do it with. So we'll be looking at Python in this class. Python is kind of a high-level programming language. It can do almost anything. You can do things like math and science, calculations and analysis. You can like automate PC tasks with Python. You can do web scraping, basically when you write a little script with Python, and then it goes onto websites and web pages and like downloads a whole bunch of stuff at once, things like that. It can do things like AI and machine learning things, you know, that really high-tech stuff, which we won't get to in this class, obviously, but it can do anything. It can do things like video games, you know, it can involve like graphics and sounds, and you just kind of design the logic behind the game, how it functions. And it can even be used to do things like web apps and websites. So it can be a backend, and some of those things you'll need additional tools, things like Django and Flash. That's kind of like an additional tool set, additional language to kind of mesh with Python to kind of run websites on the backside of them. So speaking of that, Python is what we call a backend language. It's capable of using math and logic to run programs that handles data along the way. And essentially, that's all a programming language is. It's essentially a set of instructions that you make that manipulate data that you give it, and then you get some output, some new data that you changed from what you put into it. It's kind of like the digital equivalent of a factory assembly line. You put some data on the assembly belt, it goes down the belt, something happens to it, goes down the belt again, maybe it splits off, some data goes down route A, some goes down route B, stuff happens on both sides. And then all the way at the end of the assembly belt, you'll get something out, and that something out might be a video game, it might be some complicated math and science calculation, anything that we can imagine that we know machines can do, Python can probably do it. In contrast to the type of language Python is, that being a back-end language, we'll just explain a front-end language, if you've seen that tossed around, is something like HTML and CSS. Those handle content and design, AKA like putting the content in a website and then styling the layout of the page, making columns, making things bold and italic, things like that. That's what front-end languages do. And they lack the key component of a back-end language, which is able to actually program in math and logic and instructions to do things with data. Python is one of the, if not the fastest growing languages, and at the same time, the most used languages by like students, hobbyists, and professionals. All the following companies use Pythons in some projects in development: YouTube and Google, Netflix, Facebook, Instagram, Pinterest, Spotify, even NASA. I actually have a friend who is a PhD black hole astrophysicist, and she is writing some Python code with NASA. She's not allowed to tell me what it is, but she's told me that's what she's doing. So it has tremendous applications. Lots of huge businesses use it in tons of different applications. But at the exact same time, it is often said to be the easiest language to get into, easiest to get going, all those kinds of things. If we take a look at this image in the file, we can see basically the question is, how can you do something so simple as print out hello, output some message in these languages? And we can see if we zoom in on Python, it's just one single line. This is a Python load line of code. You just say, well, we want to print something. So let's say print, and then hello, we just put a message. And that's quite easy, one line. And that's what we would hope coming in as new students who might be a little bit anxious about coding. And that's in contrast to kind of most of the languages surrounding it, all these different languages. If we look down like at this big assembly box, this is a different programming language. We can see a lot of complicated things going on. Just to do something simple like print a simple message, you need a dozen lines, lots of confusing things in all of these. But one of the biggest things about Python is how human readable it is. It's basically just like the English language. It doesn't have all these complicated symbols and technological sounding things to make the code. So write Python code. Google Colab is a type of software that can basically have notes files. We just have some kind of plain text. And you can see if you click on each little box, you get a little highlight. And you can see if we click on this box, this is what's called a code cell. This is a text cell. This is a code cell. We can even add in new cells if we want, so we can kind of build up a document. And so we can do exactly what we saw above. We make a code cell. You can do it in this one if you want. And then we can just try putting in what we saw above. So we can say print. It's what's called a function, which we'll talk about in a little bit. But that's basically something, it's a pre-built code with the name print that does something when we give it some input. So basically, I'm going to put my function name. I'm going to open some parentheses like this. All functions get followed by parentheses to denote it's a function. And then inside, in quotes, I can just put any message I want. And then to run Python code in Colab, we can just go ahead and click the little play button to the left. And you can see it's still loading, but this is what comes out at the bottom. Print takes a message and prints it to what's called the console, which is just kind of the output to let us know special messages that we want to pass out of the code to see the final output of the data, things like that. So you can go ahead and put that line, click play, and then you see the output down in the console, and you can change this as you want, and then you can just run it again, and you'll get that new output down below.
Excuse
so we
me.
know, yeah.
Can you please repeat what it is, what it means by just hover your mouse over a cell? Can you please repeat that? That's the one I was referring to that I didn't get yesterday.
Oh yeah. So I'm going to move my mouse on the page, and then you can put the mouse on top. You can see this is kind of a gray box, and the same down this way. So just put the mouse on top, and then if you just left click down, you can kind of see it gets highlighted.
Oh.
So as you click, you kind of select that cell. And then if we select a cell that's a code cell, then we get the play option on the side.
But when you took your mouse over output, it showed something, right?
This message?
No. Go to the green line, the
like this.
Green line output, put your mouse over output. The last word in that sentence 4, green line. Green colored line. No, next line.
This one?
Yeah, right. When you can you put your cursor over the word output?
I don't see output. What do you mean? Oh, this.
Yeah, this. Right. Yeah, when you put it there, something showed up, something came up, right? It code or something.
Oh, these.
Yeah, right. That's the one.
Yep, we'll talk about that in just a little bit. But basically, any of these boxes that you can select, you can then put the mouse at the top of that box. And I could do the same with this and the same with this one. And it basically lets us put in a new cell to the document.
Oh, okay.
I put all the blank cells that we need in, but we'll talk about how to use Colab itself in just a second. So yeah, we'll get to that, yeah.
Is Colab an editor? Is that we can?
Yep, it's basically a piece of editing software. So like things like Microsoft Excel, you make spreadsheets and then you can run that. This is the equivalent of editing code. Yep.
Any language code or only exclusive to Python?
This specific one, Google Colab, is just Python actually.
Oh, okay.
Lots of websites can do different languages, but I have this one because it's just Python, so it just has what we need.
Okay, good to know. Thank you.
Okay, but yeah, we'll get to how to use Colab in a second.
Another question, excuse me. When you showed us the various languages and how they, some of them are more complicated and all of this, like Python, I see that there is only, after the parentheses, one, quotation.
Yep.
While the other ones require 2. But now when I see it here, it does it with 2. So does it matter or it does it not? Or
it does not. And we'll get to that in a little bit once we actually get into the code. This is just a little demo. But yeah, as you can see, you can choose which one you want. You can use double quotes if you want. You can use single quotes.
I see.
You just have to be consistent. You can't do something like this. You can't have opening, single, closing.
Yeah, of
double.
Course. Yeah.
Yep.
Yeah. I just didn't know how precise it is. Yes.
Yep. That's a good eye. Yeah. We'll talk about that in a little bit as well. Okay. So yeah, we ran a sample cell, and now let's actually take a look at a sample little snippet of Python code, and we'll kind of see. Obviously, we don't know how to build this yet, but we can see how human readable the language is and how relatively uncomplicated it is next to even this stuff to just print one message. So if we take a look at this, we can see, we can read it top to bottom, left to right, just like the English language. We can see we have something called change in my pockets. We can kind of guess equals means change in my pocket is equal to something. Then we have something that's in these brackets that we don't know what that means. But then we can see what maybe is items in a list. We can see 0.25, 0.25, 0.10, 0.1, 0.01, 0.01, 0.05. And we can kind of intuit that maybe we have some type of data list, maybe that we call change in my pockets. And it looks like this is coins. It looks like 25 cents, dimes, nickels, pennies. So we made some data. And then on the second line, we see something like total equals 0. This is kind of like the line above. It's some type of data, we can assume, called total, and it's equal to 0 at the moment. And then even this next line, which we won't know how to build until next class, we can kind of intuit just on how easy Python is, kind of what's going on. We can say, it's saying for coin in change in my pockets, colon, total plus equals coin. So it seems to be doing something for each coin in change in my pockets. Looks like maybe it's adding that coin to the total, which was 0 at the beginning, but then we add up to it, and it looks like we might be summing up all the coins in this data object that's maybe symbolizing, you know, the cash in my jeans pocket. And at the end, we know a little bit about this print function. It's going to send a message to the console, and it actually shows it down below. But if you don't see it, you can again push the play button, and you can see, yeah, it did exactly what we could kind of intuit. It printed out 0.67, and that was just adding up all the coins in this object. And in this example, we can kind of see a lot of the ideas of not just Python, but of programming languages in general. We have, looks like we have some data objects. We want to keep track of things. And then we have a little bit of like syntax to make some commands, you know, do something. We see something that looks like just a little bit of simple math, even though we don't quite know how to do like plus equals. Why do we use that instead of just plus? But that's okay, we'll get to it. But the point is that it's relatively human readable, and it's not overly complicated, even only a few minutes into Python, I hope. So again, Python is one of the biggest languages today based on how easy it is. Professionals who do coding need a lot of like background theoretical knowledge about computer science and all those things. And even if you do different languages like C and C++ and maybe Java, you might need a lot of that background knowledge just because of how complicated the language itself is. But with Python, it's quite easy to get going because the way they built the language, they made it so simple to use. It's kind of like if you do a complicated language like C, you kind of like need to know the equivalent of building, fixing, and driving a vehicle. Well, with something like Python, you don't need to know how to build the vehicle. You don't need to know how to fix it. You can just pick up how to drive in just a little bit. It's that easy to just get going. If we take a look below, and again, if you don't see this output, you can click on the play button. This little list that's being output, and this is a special function in Python, just like print. What it's showing is basically the dictionary of everything that's in Python. So when we said Python is kind of like a language, like English language, it is, everything is in plain English. You can kind of see all these things and maybe even guess what a lot of them mean. We might be able to guess what if means and except finally. Those seem to all make sense, and we can kind of imagine, you know, coding a set of instructions and needing to say, you know, if something, if not that, else this, you know, so on, things like that. But this is basically the sum total of all the vocab that we need in Python. Besides some additional basic symbols, like the equal sign, plus, minus, multiplication, some colons and some parentheses. All of this is basically Python. We just need this. We just need some punctuation, and everything else that we build in Python, we basically name it ourselves. So if we take a look back up this way, we can see most of this is things that I named myself, and that's because it's a data object. So I can name the data as I want, so it makes sense, and I can read this like a human sentence, not like some complicated machine thing. So in
Excuse me,
these,
Matthew,
yeah.
Can you please say one sentence among all those keywords? I see DEF, what it means, and ELIF, I think it is ELSIF, right?
Yep, this is going to be, this is ELSIF, it's an abbreviation, and we'll actually get to if, ELSIF, and else today. So we'll get to them as we come to them. But yeah, that's what they mean, exactly.
And DEF, is that definition or default or what?
Def is, yeah, definition, and we'll take a look at that
Okay.
next class, actually. But yeah, yep. So
Okay,
it's all just basic English, some things slightly abbreviated, but all just basic plain English.
okay.
And lambda, what is lambda?
That we won't take a look at. That's a bit complicated. But
okay.
most of this, by the end of the class, we'll know about half of these. And just half of them is basically 75% of anyone's Python code. The rest of them is only special cases and really complicated problems. You really only need a handful of these to do basically anything. So taking one step back from Python ahead of going on to making the actual code, let's talk about this Google Colab. So Google Colab is a free website that Google provides with a Gmail account, as you all know. It's actually running a type of thing called Jupyter Notebook. And what that basically is it's a special type of editing thing that combines being able to write and run Python code with just plain text. So if we take a look above, this is some Python code. You can kind of tell it doesn't have the same font and styling as something like this. This is just some plain text. And it basically lets us take notes, run some Python code, and then take notes again. So it's basically a student tool to study Python like this. So that's why we chose this to run the class in. How can we use Google Colab? Well, as you asked a couple of seconds ago, if you click on any cell, and that's what we call any of these boxes, if you click on any of them, you can then put the mouse kind of at the top middle of the box, and then you can add in a new cell. So if you want to take additional notes in this class, you can go click a box and then click add text. And then you can see, you can take notes in the box. Then you can just click out to kind of save it and put it on the page. To go back and edit it, you can double click on it. And then you can kind of get back in edit mode. And then you also, just as a little added fun, if you want to, you notice you have a couple options up at the top. You won't need most of them, but as you can see, you can do things like, say I want to make this boldface, you can highlight it and click bold. And then when I save that cell, it's now bold. If I want to make it italic, I can highlight it and click italic. And now I have bold and italic.
How did you get to the edit mode? Just by double clicking?
Yep, just double click on it.
Oh, okay, okay.
Yep. And then to, so double click to get in, and then just click any place else outside the box to kind of save it and put that cell away. So that's the basic gist of it. All the notes that we need, I have typed, so you won't need to take too many additional notes. And then secondly, if you click on code cell, you get a code cell. You don't get any bold and italic options because you just type Python code and then you click play.
Matthew, you already have some cells in this, if I call this an editor, but when we start the editor, then also we'll have the same options to do the text and code?
Yeah, you should see the same options that I do if I understand what you mean.
Okay, okay.
Yep. Okay, so that's the tool that we will be using, this website. And you can take a look at it today and at home if you want to see all that it can do. But let's get on to the Python itself. Talk a little bit at how we construct the language. Again, if we think of it as a language, kind of a subset of the human language because it's so based in just basic English vocab and syntax. So a couple things to get us going. And we can see this example that we saw a couple seconds ago again. Each line in Python usually contains a single code instruction. So when we want to stack code, we just put each one on its own new line, top to bottom. So if we take a look at this, I basically do one thing a line. On this line, I'm making a piece of data called change in my pockets, and I'm assigning it some values. And then that's the one thing. So then I jump to a new line. On this line, I make something called total just to initialize it. And then I go down and I say, let me loop through each coin in my pocket. Then on this line, I say, each time I get a coin in that loop, let me add it to the total. And then the last thing, just one thing again, print out total like this. Indenting is crucial in Python. In a lot of coding languages, indenting doesn't do anything. But if you take a look at this code cell, you can see that I've indented these two lines. And while we won't explain right now why we did that in this specific instance, just know that we had to do it. And I'll let you know when you have to indent and outdent. But indenting basically distinguishes a discrete block of code. So if we take a look at this line, which we'll do next class, is basically saying, take change in my pockets and give me one coin at a time. And then I've indented these two lines because I'm applying both of these lines each time I get a coin. So if you click play, you can see I'm running a lot of lines of code. And that's because I'm running these two indented lines each time I get to a coin in my pocket. So we can see I have print coin, and we can see I'm doing as many basically steps as I have coins in my pocket. So I got 0.25, 0.25, 0.1, penny, penny, nickel, and then my total at the end. So the reason that we indented is because we do these steps each time we get to a coin in my pocket. And that's a little convenience tool to do the same thing many times across a couple pieces of data like this. In Python, we have, in addition to these couple things like if, elif, in these little human, English vocab, we also just have punctuation symbols. So some of the obvious ones we'll look at today, we have like the plus sign, the equal sign. We have some commas, some colons, a couple types of brackets. We have these type. We have the typical parentheses, and we'll see when and how to use each of these. But essentially, that's all we need. We need indenting, some vocab to do Python code, and some punctuation to kind of set it up and tell Python what to do. And lastly, as we write Python, we might run into bugs. And a bug is basically a time when the code fails and it won't run. And that's because we have violated one of these rules above. It could be something like we have some bad logic and Python can't make sense of it. It could be something like we violate the indentation rules. So if we play this one now, we see we don't get an output like previously. We can see this kind of looks like some bug message. It didn't calculate what we wanted to. It wants us to fix the code. So if we do something like bad indentation, we could get a bug. If we do something as simple as like dropping a colon, if I delete that and then I play it, we can see I get a bug again. So as simple as the list of kind of Python vocab and punctuation is, if we kind of fail to use it strictly, we can run into a couple bugs like this. So if you get kind of a message that looks like this, we'll just have to take a look at the code and check that it's fully up to snuff like this. So just some basic kind of outline of how to build the Python language. But now let's get going into actually seeing all the components of Python and actually writing some code of our own now. So we go down the page. We'll kind of build up a toolkit of actual Python code now. So tool one in Python and all kind of coding languages is something called a comment. And anytime we type a hashtag in a code cell, so I have a code cell, this basically makes what's called a comment. And a comment is basically a piece of text in Python code, which we tell the machine is not Python code. So we can see if I instead do something like this again, I do a little print message and I play this, we can see it does what it expects. It knows it's Python code. But now if I put a hashtag in front of it, we can see it kind of changes what it looks like. It goes to all green text. And now if I play this, we can see we get no output. And that's because I've told Python, this isn't actually code. And the reason we have this kind of tool is just to be able to add little notes and explanations to code. So basically I've canceled this out. I could also do something like this. I could put a little note like this, like how to print a message, put a little note inside my code, and then below it, I'll have actual Python code because I don't have a comment. So we can see this came out, but this isn't code, so nothing happened to it. And finally, we can see if I don't put a comment on that, and then I click play, well, Python is saying invalid syntax. This is again one of those bug messages. And that's because it thinks this is an actual statement, an actual piece of Python code that I wrote. But obviously it's not a sensical piece of Python code. So that's why it failed. So in some comments you can use to kind of cancel out lines of code, and you can use them to kind of leave messages and kind of explain what you do inside Python. You can also do something like this. And what's happening is anything to the right of the hashtag is kind of canceled out as a comment, but you can still have code to the left of it. So in this case, I put a hashtag at the beginning of the line. So the whole line, anything following it is a comment. But on the second line, I do code again until I get to a comment, and then only half the line is a comment. So you can use that to add little notes to code as we go along to kind of explain what's going on and take notes like that. Next, something we've taken a couple looks at already, something called the print function. And this is a built-in function that lets us kind of output data to the console. And again, the console is just this little box below the Python box that displays some message as we give it. Inside the parentheses, we can put any message we want. Again, like you said, Celia, we can do it in double quotes. We can do it in single quotes. We just kind of have to be consistent. So we can put a message like this, and we can put a message like this if we want. So we can see while Python is strict with some things, in this case, it doesn't really matter what type of quotation we use. So it's not so strict in this sense. They both do the exact same thing. In addition to being able to put some message inside of it, we can also put multiple messages inside of it. So if I put a comma, and then I put a second little message, this is also going to come out just fine like this. So we can kind of stack as many messages inside print using commas like this. And we'll see why this is useful in a little bit once we do some beyond the basics coding. That's just a little introduction to the print message. And this is kind of how we'll see what's happening in the code as we go along. We'll put some code in, but then we kind of need to know what's being calculated, and we need to manually tell Python to display it on the console down below. So ahead of actually doing anything in Python, we can't do anything unless we have kind of things to do it too. So we need to talk about data objects because that's the basis of any coding language. You put in some data into the code, and then you manipulate that data. And then the end result of a program is some output, some manipulation of that data. So we can think of data objects as the kind of nouns of the Python language, the Python code. They hold the stuff that we can use. Sometimes we'll see them called variables. Most of the time, people just call them kind of objects. And what an object is it's basically a box of information that in Python always has three things attached to it. Thing one is the kind of name of the box itself. The second thing is the contents of the box, the value, and that is the piece of data itself. And we can kind of change this as we execute a program. So we just think about these two things in the beginning, and we look down below. We might make a object that's labeled name, that's its name, but its actual value, what's inside that kind of the idea of a box, is the value mat. So that's how we can think of objects. It's kind of boxes with contents inside, and then we have some name that we use to call them and use them. And then the last thing that we have to kind of associate with objects is what we can kind of think of as the shape of the box, and that's something called type. Oops. And different objects, different pieces of data have different types. So we could have something like a number type, if we have like 10, negative 100, 3.1. That's one type. A different type is just like kind of text data. And we'll see these different types of data as we go along. To make any object in Python, we need what's called to assign it. And basically that's just putting an equal symbol between the name of the object and its value. So almost any object in Python, we do something like this. We say, I'm going to make a name, and that's going to be equal to its value, in this case, mat. Second example, if we have some program that's calculating the cost of something, we might say, okay, let's make something called cost, and its actual value is going to be 99, stuff like that. And we'll see why this way of thinking is useful in a little bit. But we can think of this as Python reading right to left, actually. So we can think of this as saying, take the value 99 and put it inside a box called cost. So now we have an object cost with the value 99 inside of it. So if we take a couple of examples, you can just get used to typing out Python code. You can name it anything you want. And then we can put some text in some quotations like this. When we want to make a second piece of data, we just go down to a new line. So I can have two objects with two different names, name and name one. When you name an object in Python, the convention is to use no capitals. and you can't use any spaces. So I couldn't do something like this. I would have to do something like this, or I could do something like this if I wanted. It's up to you. We just can't have any spaces. And kind of the last law of making objects is I can't begin with a number like this. I can't do one name. You can see I get a little like typo squiggle. I have to do name one like that. Or in this case, I would call it name two. So each object has its own name and each has its own value like this. And the usefulness of objects is that we only have to define this value once, and then we can use them in multiple places again and again by calling on the name of it, not its value itself. And we'll see once we begin to use these data objects why this is useful. So let's talk about types. This above applies to kind of all types of objects, how you make it name equals value. But let's talk about the specific types of values in Python. And we can think of these as the basic building blocks of Python. And what we can see, this little handful of types, is essentially all you need to code Python and do any type of data in this and in any language. So the initial type is what's called a string type. And that's just a general type of data. It's basically text data. So we can put text into this. But in addition to text, we can also have anything that we can type in. So we can have punctuation, digits, things like that. So one example would be, like my string equals hello. So I have a box called my string and its value is hello. I could have a box called date, and then I could have July 7th, 2021. I could have all those symbols in a text type object. And then we can see I could have something simply called Hamlet, and I could have that equal to, and then we can kind of imagine, I put ... at the end. We can imagine the value of this box is the whole play of Shakespeare's Hamlet. It can be that long. So I can have a tiny little thing called Hamlet, and I can have the value of that box be the whole play of Hamlet. So we can see when we begin to use a coding language, we get a lot of convenience like that. We can have a huge amount of data in just a little thing we call Hamlet like that. Second two types of data, kind of the same thing, both kind of quantitative types. Type one is just kind of integers, whole amounts, positive or negative. So we can have 10, 0, negative 1,000, positive 10,000, anything like that. And we often call these int in Python. And then the second type, which is kind of the same thing, but technically a different type, is it's called a float, but this just means any decimal amount. So in this case, 1.0 would be a float. Well, if I just had 1, that would technically be an int because I don't specify the decimal. These can still be positive or negative. So I could have negative pi. I could have positive 10,000.1279. It's just a value with a decimal. So we have text type data, two types of data that we can obviously do math with. And then the last basic type of data is what's called a bool, or a Boolean data type. And this is a special data type with basically only two possible values, that being true and false. And this is crucial to coding. If we think of coding as just instructions to automate some process, some steps that we do, obviously we can imagine that we need kind of true and false values when we ask something like, if X, then do Y, else Z. So we need true false values to be able to say, if X is true, then do Y, else if X is false, do Z. So as we kind of imagine Python as just a set of instructions, we kind of need those switches to see when and if we'll do things. And that's when we use Bool type values. That's all the basic types of objects in Python. You can basically do anything with these. We got text, quantities, and true false. And the next big collection of data types, which we won't get to today, is just a type of data called a sequence. And that's basically a type of advanced data object that itself contains data objects. So if I have a couple strings called like name equals Matt, name2 equals Jen, I could have a sequence, which is just a collection of name1, name2, ... name50. So I could have something called names equals name1, name2, name3. So we can think of sequences as just buckets of these primitive types of data. And we've actually already seen that. Let's go back and look at an example of this. This is a data sequence. We now know this is a float type value. It's a decimal point. And what's happening is we have what's called a sequence that's kind of holding multiple of those quantities inside itself. So it's just a box of boxes in this way. And lastly, each type of data has a special set of like things that can be done to them. So obviously with these two quantitative types of objects, we obviously can do things like math to them. Well, things like strings, which have text in them, we obviously can't do math to those, but it has its own special set of things that can be done to it. Like we can combine it, we can slice it up, things like that. For example, the string called Hamlet, obviously we can't just do math to that, but we could do something like chop it up into individual lines of the play. We could do something like find all of Hamlet's lines, so we can just get a subset of Hamlet lines and things like that and kind of do text analysis to it. But that's a couple classes down. Today we'll be focusing on kind of mathy type data. We'll be looking at these two guys. So let's take a look at, let's build a couple of these data objects just so we get into the habit of how to type out Python. So we'll do one each of these and we'll see any object, we just do name equals value like this. If I want to do a string type object, I can say like my string, that's my name. Inside of this box, I'm gonna do Hamlet. Next, I'm just gonna use comments to kind of add notes to my page. I'm gonna say, let me do an int type object. And again, that's just any whole quantity. So I can say my number equals 200. And then lastly, we can do a float type, which again is just a decimal. And then I could do something like, I'm gonna call it my float, and then I'll call it 200.55 like that. One little thing that we see, even though we build these the same way, name equals value, we can see when we do ints and floats, we don't use the quotations like this. When we have quantities, we can just put them kind of naked like that. We don't need quotations. That kind of helps differentiate those, how we build them. And then lastly, we can actually kind of check what Python thinks of these objects by using a second function called the type function. And this kind of gives back the type of an object. So if I do something like, I'm gonna call my function by putting the function name in parentheses, and then I'm gonna put my string like this. And then when I say it gives back, I mean it basically changes into the output. So I can say output equals type my string like this, because any function is basically just a step on an assembly line. Some input goes in this case being my string. Something happens inside that step. We can't see what it is because type is kind of given to us by Python. We don't have to define it ourselves. But then something comes out on the end of that based on the data that we put into it. And that's what we do with this. Just like we made an object up this way, we can also make an object by taking the output of a function like this. And now, we obviously don't know what output quite is, but this is the usefulness of the print function that we know about. So now I can do print, and then I'm going to put output, and this should tell me what actually is output. So if I click play, we can see I just have one line, and that's because I just have one print statement. And type is basically telling me output is a string type like this. If I change this to my float, it now becomes a float, and so on. Okay, so let's talk a little bit about string type, but like I said, most of the class will be doing some math type stuff, so we'll be going on to this type of stuff in a second. So strings is an object that can have basically anything that you can type on the keypad, A to Z, capital, lowercase, any digit, punctuation, spaces, special keys, exclamation points, anything you want. And like we said, we just make it by saying name equals value inside quotations. Like you caught a little while ago, it can be single quotes, it can be double quotes. It doesn't really matter in that sense. But since you did catch that little nuance of the language, let me show you why that is, why we have both options when making a string. So if I make an object, I'm going to call it Hamlet line. That's going to be the name of my box. And then what value am I going to put inside of that? Well, I'm going to put some line of Hamlet. So I might say, Hamlet says to be or not to be. And as we can kind of see, we get those kind of typo squiggles. And when we run the code, it has a bug. And so what's happening is because you enclose a string in between two of the same quotations, Python thinks this is the value, and then it thinks this is some additional code at the end of it. So what we need to do is we actually need to switch which quotes we use inside of it to be able to then, let me print this out, use quotations within inside a string. So you can see by switching them, it doesn't break Python like that. And we can do the same thing, but opposite if we want. If we want to wrap the outside in single quotes, we can do that. And we just change the inside to double quotes like this. And because Python is a machine, it's just a bunch of instructions coded in. It just needs us to be explicit like that so it can tell the definite beginning and end of a string object like that. Okay. So one of the main types of objects, just kind of quantitative type data, ints and floats. We can use both to use math, even combined. So let's practice typing out code again. I might say, let me have some object called grade. I'm going to set it equal to 95. So creating an object called grade like this. And then again, just get used to using function like this we can see anytime we have an object in Python like this, when the code actually runs, it's instantly switched with its actual value. So even though we put grade into the print statement, as soon as we push the play button, this gets switched to 95, and so that's why 95 comes out like this. Excuse me. Again, we can check the type of 95, and we could even do something like this. So while previously I said output equals type grade, I can actually just skip that step, and instead of doing print grade comma output, I can just say print grade comma type grade. Because just like objects get switched with values at the instant you click the play button, as soon as we click the play button, any function that gives out some output, it's going to kind of go away and just the value is going to be left in its place. So I still just have a print statement that's printing out two values. It's just that this is one step away from a value. But as soon as I click play, this becomes a value, this becomes a value. So it's kind of the same thing, just minus that one step of something like this. These two things, the same thing. I just have a kind of a middleman in between, but you don't need to have that with Python. It's up to you.
Could we just say output grade? What will happen? What would happen?
If you do what?
Output grade.
Like on its own line?
Yeah, output grade. Yeah, I didn't think of comma, but anyway, yeah, like something like that.
Let's see what it does. So it actually, this is actually a nuance of Google Colab itself. What's happening is in Google Colab, it basically always takes the last line of code. In this case, I just have one line of code, so it's the last line of code. And it basically automatically adds in a print statement and just prints out the value of the last line. So while in true Python, if you had a true Python file, you wouldn't be able to do this. You would have to do this to actually see it on the console. Since this is kind of like a student notebook teaching tool, this is kind of implied with any last line of code.
Oh,
So we can see.
so grade is 95. Yes, we assigned that, but
Yep.
output is float because output also we assigned as type of grade. That's why, right?
Yeah, exactly. Yeah.
But isn't that output is a key word? I was thinking just output space grade.
Let's see. I think that will come out in a bug.
Oh, okay.
Yep. So in Python, you basically, when you have multiple values, you basically always need a comma between them to say, this is one value, comma, this is a second value. So just a little bit of Python syntax we got to pick up.
The output is not a keyword then, right? Or
Nope,
it is?
it's a name that we gave it. So it's an object.
Yeah, we gave that name. It's an object.
Yep.
Correct. Okay.
Yeah,
okay.
exactly.
I'm
Okay.
good. Thank you.
Yep. And then again, let's take a little advanced look at using print again. Say we want to print out some statement like Matt's grade is 95. So let's open up a print statement, a print function, and then let's kind of combine these values, just some static text to output some message. And actually, let me come back up. Just going to make this object again. So now I have an object called name. I have one called grade, and now I can combine these into kind of a big message. So I can do something like, let me print name, and then I'm going to print some kind of base value that I haven't put inside of an object box. It's just kind of a naked value that I made on the spot. Oops. I'm going to say, so this is going to come out as Matt's grade is, and then I can go like that. And then we can print it out. We can kind of see, we can kind of combine just like static text with these dynamic values. If I change this, now name is equal to John. Well, now when I come down this way, this is also going to change to John as well. And let me point out, you can see as I kind of add spaces in like this, it doesn't really affect anything. Usual Python convention is to kind of put a single space between anything. But as you can see, this is one of those things that actually won't break the code if you kind of do it like this if you want. You could do it like this if you want. Spacing in this case doesn't actually affect anything, in case you had a question about that when you saw it like that.
So is there any way we can take the space out after John before apostrophe S? Yeah, right.
Yeah, that's a good eye. So what we can see, and we can actually see down this way, we have two spaces on this side. And that's because in between each value of the print statement, it's automatically putting in a space between each value. So that's something that's kind of built into print. We can change that. We can kind of tell print, don't use that default of putting a space in between each one. So you definitely can do it. We just won't look at it today. Let's get the basics out of the way. But
All
yeah,
right.
definitely you can change that. Good eye.
Okay. Okay.
Okay, yeah, so we've looked at data types, so we know how to make them now. And we just got to get one last thing out of the way, and that's something called casting, or actually typecasting. And typecasting is just the process of changing some existing object, its type, into a different type. So say an int to a float, or a float into an int, things like that. Because now that we have so many types of data, we kind of have to ask the question, which types can you use with which types? If you combine two types, is that going to break the code? Does it make sense to use two types in the same statement? Things like that. So like we said above, you can use ints, whole values, and floats, decimal type values, in combination seamlessly. You don't have to do much. Python kind of automatically says if you add 5 to 6.7, even though it's an int added to a float type, it can do that without any problem. But what happens if you try to do something like a string type, my name, +7. So we have a string type and an int type. Well, and we can actually see it in the bug. We have a type bug. We can't do this. It logically doesn't make sense. We can't add a quantity to a string like this. We can't do math with text and stuff. So we will run into some issues if we kind of mix up types in some case. Let me get this out of the way. But we can see on top of print and the type function, we have some new functions, the int function, float function, and a string function. And basically these change a given value to the value that it is, if it can. So let's take a look at that. So if we do something like, let's call x equal to 2, and then let's just check, let's print out x, and we'll just check x's type like this. So we can see, yep, it's 2, and it's an int type because it has no decimal as we thought. But now, if we want to, we can say, well, let's say y is equal to float x. So we want to take x, take that 2, and make it into a decimal point. Now we could do print y and type y. And we can see x used to be just 2, and it was an int, but then we changed it and put it in a new box called y. And as we put a copy of that into the box called y, we changed it to a decimal, and we can see it's now 2.0, and it's a float type like this.
Excuse me, Matthew.
Yeah.
I didn't get why that word class is coming there? I see the integer and float, right?
Yeah.
And when it says type of X, type of Y, it says int or float. But where is that class coming out within that?
So this is, so it means it's giving back the type of what it is. So it's type int, it's type float. The little class denotation is some like deep level Python that doesn't really apply to us. We don't have to really pay attention to that. We might talk about it in a little bit at the end of the class, what a class is. A class is basically how Python is making these different types. It's kind of the behind the scenes of how it's actually understanding different types of data. And so we can think of class as kind of just a different name for type, but like the advanced name, if you want to get into the complicated stuff.
No, okay, I hear you. So I'm trying to understand just for now, for this class. So print within parentheses X and type of X, right?
Yep.
So for X is producing 2 and type of X is producing within angular bracket class comma int, right?
Yep. Yeah. So type X is a function and its output is it's like a special type of string. And it's saying class, but we can just think of that as meaning type. And then it just says the type. It says int, it says float like that.
Okay.
So we can kind of skim past class because it's kind of high level at this point.
Okay. Okay. Thank you.
Yeah. So Python and kind of PCs in general are actually kind of extremely stupid. They can only do exactly what we tell them to do as exactly as we describe. A machine isn't useful because it's intelligent. It's useful because it's extremely fast. So while a machine in Python gets confused if you do something like adding the string 1 to 2, or if you add the string digit 1 to 2, it gets confused by that because it doesn't see these as an int type. It thinks that's a string type, which it is, and it knows it shouldn't be doing math with that. So we kind of have to be specific about types and only add kind of mathable types to types that can do math like this. So while Python gets easily confused by this, while we as humans can kind of intuit, it's a little bit unusual that you would spell out 1 and then add it to 2, but we know that means 3. Python can't quite do that. We have to stick to the rules of how to make the language. But then once you put in statements as Python knows it, it could do it just as fast as humans. And in fact, it could do 1 million calculations in half a second, which is something humans can't do. So the usefulness of Python and machines is in its speed. We just have to watch that we be strict in how we write it out because it'll only do exactly what we say. Okay, so we have the almost all the objects out of the way. We know how to make data. So now let's actually begin building up that toolkit of what we can do with data. Let's change data, make new data, often combining old data. And the simplest way to begin is just we'll be focusing on the math type data. So let's do some math with this data. In Python, to do basic arithmetic, you just use the typical symbols, plus, minus. Division is a slash, multiply is an asterisk. And we can kind of just do it that easily. So let's look at an example of addition. We need to make some data to do math to. So let's say we'll call something A. We'll set it equal to 10. Let's jump to a new line so we can have a new statement. And then let's say A is equal to A plus 10. And then we could check what A is, and then I'll explain what's happening. So we can see it comes out to 20, as we would expect. What might be getting you is this line. But if we think of how we make objects, we have to take a value and put it inside of a box. And we can only use what's in a box if we put it inside. So we said, again, reading right to left, like I said in the beginning, take the value 10 and put it inside A. And then on the second line, right to left, it says take A, and anytime you call an object, you just take its value out. So let's say take A, 10 plus 10, that equals 20. Take 20 and put that into the box called A. So we basically replaced, updated the value inside A. So that's why we need to do it like that instead of just like this. So if we did this, A is still equal to 10 at this point, because even though we added A to 10 and got 20 on this line, we didn't put that 20 back inside A. We didn't update A. So that's why we need to kind of do the math like this. We need to do the math and then say which object it goes back inside of. In this case, just kind of updating itself.
Again, Matthew, I'm sorry if I'm asking too many questions.
No,
In
it's
that
okay.
last statement, like where we are saying print and within parentheses A, I'm just very curious to see if we say like type A, will it be like a bug? Within parentheses, yeah, in that one there, type
Like,
A. Yeah,
like this?
yeah, right, exactly.
No, we can do that. So like we said, anytime you have,
Oh, again, it is coming back with class
Yep.
and I. Okay.
anytime we have a
Thank you
function,
so much.
yep.
Mm.
Anytime we have a function, when we click the play button, that function kind of instantly gets replaced with its value. So even though we see type A, when we click play, that's going to become its output. So then it really is just print some value. So that's why we can do a function in place of a value, because a function always becomes a value anyway. So we can kind of skip the middleman of doing something like this again. And then doing something like this. We can just skip that and just say print type A. Exactly.
For taking the time.
Subtraction, same thing. It's really this easy once you get this idea down, putting the value back inside of itself. So let's look at each of these operations, but we'll add one step in to kind of see how to do stuff the Pythonic way, as people say. So an example of subtraction, let's make a new object. We'll call it 100. And then instead of doing something like this, maybe we want to do something like this instead. And then we might want to do something like this. So what we've done is we've said, put a 100 in a box called A, then take B, which is 100, and minus 20. But instead of updating B, let's put that result in a new object called C. And then as we can see at the end, the point of this is that we have access to both the new result and we have access to the data at the beginning. So instead of kind of like overwriting the data that we had up this way, we kind of erased A equals 10 and A was equal to 20 at the end. In this case, we still have access to B and the new C. So in a lot of functions, you have to make the choice, can I just keep updating values because I only want one final output? Or should I keep track of all my data along the way in case maybe I need B again? I want to hang on to B. So instead of overwriting B, I'll make a new C. So I have access to all of them at the end like that. So that's a choice we'll have to make as we make these functions in Python. Let's take a look at multiplications. We'll say D equals 2. And then we'll say, we'll go back to this updating D. And let's print out D. So D equals 2. D times 5 is equal to 10. Put 10 inside D and update it, and then just print it out. So that's kind of like addition. We kind of did the same thing, just updated D. But let's add one little thing in. Instead of this notation, let me space it out a little bit. Instead of this line, and let me comment it out, you can do something like this. And when I click play, we can see I still get 10. And what this line is it's basically an abbreviation of this line. It's basically saying D is equal to itself times 5. So it's just a abridged way of writing the same thing. You can choose which one you want to do it to, which way you want to style it. It's up to you. But you will see this a lot if you see Python anyplace else. So it's up to you which one you want to use. You can use this one in the beginning if it makes the most sense to you as you get used to the language. But eventually you probably switch to this kind of quick way of writing this out. So then again, this is saying D is equal to itself times 5. And we can do that with any of these things. So instead of A equals A plus 10, we could do the same thing and say A is equal to plus equals 10. Let me comment this out. And then we can see we still get 20. So this is just a abbreviated way of saying this. So it's just a way of updating itself using the operation and using some new value to do something to it. If we go down to division, same thing. Let's just say EF, and then we'll say G is equal to E divided by F. Space this out like convention says. Print G. Let's take a look. And we can see it comes out exactly like we would expect. But what we can note at this point is that both of these come out as int type. And this automatically changes to float type. And we can check that down this way. We can say, let me check type E, and let me check type G. And yeah, so we can see Python can do some things automatically, even though we had two kind of whole amounts, no decimal points. As soon as we did some math that had to come out with some decimal point, Python automatically handled that. And instead of giving us back an int, it gave us back a float like that. Two last like basic math operations. One is exponents. And this, you just use the symbol double asterisk like that. So if I say like 10 multiply 3, we can see that equals 1,000. Because this is a exponent, it's 10 cubed like that. So that's how we can do exponents and if we need. And then one last type is a special type of division. And let me set up the example. So say A equals 10. And then let's say B equals 10 and C equals 11. And then let's print out B special type of division divided by A, and then also print out C special type of division divided by A. And we can see both of these come out to 1. So I basically said 10 divided by 10, well, that equals 1. But then I said 11 divided by 10, that's not equal to 1. But what this type of division is it basically checks how many times a quantity divides wholly into a second one, and it skips the decimal. So if we stack up this inside the print statement, C true division by A, we can see it actually came out to 1.1. But because we chose this special type of division, we just said we don't need the decimal. We just want to see how many whole times A can divide into C. That's mostly a little bit of math, but you can do it in Python. Okay, so a little bit.
Can
Yeah.
you briefly repeat the exponent once again, please, if possible?
Oh yeah. Yeah, so exponent, it's just double asterisk to denote exponents instead of multiply.
Mhm.
So we can see, let me do this down below. So we can see this one is 10 times 3. Well, this one is 10 to 10 cubed. 10 times 10 times 10.
Oh.
So we just use this symbol to mean exponents instead of just plain multiply like that.
So when you said print 10 asterisk 3, that is 10 multiplied by 3. We didn't, 30. Okay. We saw 30, right? Yeah. Print.
Yep.
Not,
Yeah, just like this, yeah.
Yeah.
Yep. Yeah, so this is a new symbol. Obviously, we didn't use this in math class, but this is just how we type it in Python. It's basically this if you did that notation in math class, but we just type it in Python this way.
Okay. Thank you.
Okay, so just a little bit of review. So basic symbols, plus, minus, multiply, divide. And then we have these kind of abbreviated ways that basically say, do some math and then assign that value to itself. So plus equals, minus equals, multiplies equals, divide equals. So if we go back up again, when did I have, yep, so like this. I could say D equals D times 5, but I can kind of skip out this like redundant text and just say D times equals 5. D is equal to 5 times itself. So we'll see this notation a lot. When you won't see it is when you want to put the value in a new object. So in this case, I wanted to hang on to B in case I maybe need it down the line. So instead of deleting B with the output, I set it equal to C. So in this case, I wouldn't be able to do this because then I wouldn't have a C because I'm just deleting B and updating it itself. So that's when you should and shouldn't use it, depending on how you want the data.
Show us divide equals.
5?
Divide equals. Like, yeah.
Yep. Yeah, so you could say D equals D times 5. And you could say D times equals 5 like this.
Yeah, can we try D divides equal? D or whatever, like divides equal, an example of divides equal.
Yeah.
Right.
Yes, if we did that. Yep, it comes out to 5. D's last value is 10. It's taking this D. So it's saying D is equal to itself, which is 10 divided by 2. That equals 5. So D is now updated to 5 like that.
So even though you created a new window, new rectangular gray box, it still gets the last value of D from another rectangular.
Yeah,
box.
so let me explain that about Colab. So each cell, when we click play, it basically runs this data in these statements, but we can use any data in this box, down in this box if we want. So if we do something like name equals Jill, and we click play, and that kind of save this inside Python, then we come down a bunch of cells and say, okay, let me print out name now. We can see it still says Jill. So even though I'm only executing this line of code, I have all the data that I've saved into Python by clicking play kind of behind the scenes. So I have all the names and name ones, A, B, C, D, all of that's kind of hiding, and I can pull it out anytime I want, as long as I previously made that object. Yes, a good question.
How old is that editor Colab? I don't know from you, the first time ever in my life I came to know about this. How old it is? Is it too old?
Oh, how old is it?
Yeah.
I actually have no idea how old it is. You'd have to, I guess we can just Google that at the end of the class.
Maybe other people in the class already know, but to be honest, first time ever, right?
Yeah.
Yeah.
Yep, yeah, it's really useful. It's nice of Google to make this free so people can use it.
Yeah, very easy and nice. Yeah.
Okay.
Thank
Yep. Okay. So we see how to do math, how to kind of do this quick abbreviated math with the plus equals minus equals. That's called assignment, when you basically say some object is equal to this. And let's keep in mind that the most basic assignment is just equals by itself, saying, you know, name is equal to Jill without actually doing anything to it. We just assign something to something. Well, in this case, we both do a math operation and then assign it to that object. So the most basic one is just equals, making an object. These make an object following some math operation. And then obviously, now that we know how to do all this math, we can kind of combine these into like a big math expression. We can use parentheses. So we could do something like x is equal to 5 plus 2 times 3, like that. We can see that comes out to 11. But we just have to keep in mind, what if we do something like this? So I'm going to set up the same thing twice, and they come out to the same thing. Obviously, it's the same thing. But what happens if I do this and click play? Well, then they don't come out to the same thing. This goes back to math class, PEMDAS. And this basically broke up how we multiply this. So in this top case, I said 2 times 3 is equal to 6, plus 5 is equal to 11. But down this way, since I'm following PEMDAS, I begin with 5 plus 2 equals 7, times 3 equals 21, like that. So we can see two things. We can see we can do as many math things at once in one line, but we have to pay attention to kind of how the math is being done using that PEMDAS from math class. So now we have a lot of Python behind us. Actually, we can do some basic stuff. So if you want, take a couple seconds, see if you can use Python to write a little bit of code to calculate the amount of seconds in some given amount of days. So I could say like days equal to, we'll pick 365. Go ahead and take a couple seconds to see if you can do a couple lines of code to calculate that and then print it out at the end. So that way you can get a feel of doing Python on your own and see if you run into any bugs. Okay, if anyone has it and you want to let me know what to type, and we'll see if it's good. Or else if you had a question and you maybe you got a bug or something and you want to ask that, you can go ahead and chime up now as well. Does anyone want to add anything, explain how to do it? Okay, well, I'll go ahead and do it. So we can do this a couple ways. We could do it quickly, and we can kind of do it step by step. We'll take a look at both ways. One way is to think, let's kind of plan out the steps of what we want to do. And I'm going to use comments to say what step I'm going to do. So step one might be to change days to hours like that. And then go from that to minutes. And then minutes to seconds. So I'm kind of planning out my code ahead of actually writing it like this. And now I can go ahead and just fill it in. So I can say, let me make an object called what I want. And then I can just say, that's days times 24 like that. And then I can say, let me make a new object called minutes. That's obviously going to be equal to what we just got last times 60. And then you kind of get the idea at this point. Lastly, we need something called seconds. And that's going to be equals to those minutes we just got, also times 60 like this. Then we can print seconds, and we can also add a little message in, put a value. Actually, let's just see what it comes out to.
I got it working.
Yep. So it should be that. So you can see we kind of did it step by step, just one little multiplication at a time. But we could also do it once we get good at Python and we don't need those kind of middle steps to go slow. We can just do it quickly. We could just do all of it in the print statement. And we could just do days times 60 times 60 times 24 like that.
Oh.
So we can see we've done the same things. We did the same math. And we just put it inside the print statement. Since any times we run a function or do some math, it's just going to get swapped out with its value. So if we click play on that, we get the same thing. We just skipped a lot of steps because, you know, maybe I'm used to Python, so I don't need all those middle steps, but maybe you want to slow down and do it step by step like that.
Quick question, Matt. I did this the second way just in one line, but the order of multiplication does not matter, right? Because I first multiplied by 24 and then days time 24, then 60, then 60. It doesn't matter, right?
No.
Okay.
Yeah, so comes out to the same thing. Yeah,
Okay.
so if we look up at PEMDAS, well, we don't even need to look at it. We did multiplication. Each step is multiplication. So if you think about it logically, if you multiply A times B, then times C, that's the same as multiplying C times B times A. Yeah, exactly.
Okay, thank you.
If we had to do something like there was mixing signs, maybe we had to add and then divide and then multiply by something, then we might need to pay attention to the way we set it up.
Yeah.
Yeah, but in this case, it's fine like that. Okay. So the next big tool in the toolkit is kind of doing like checks in Python. We know how to do math now, but now we can do expressions and saying like, is something equal to something? Is something not equal to something? Is something less than something? And the opposite is something greater than something. So we can do these using, you know, these symbols look like something we know, the less than and greater than symbols. If we want to check if something is equal to something, you might think we just do like 10 equals 10, but we've already used the equal symbol to assign, to do assignment, make an object. So we can't use that symbol. So we use a double equal sign, and it basically is saying, is this equal to this? And then the inequality basically saying, is this not equal to this? That's actually just minus, exclamation point equals. A little bit funny. You'll see this a lot in coding, but not in math class or any place else. So this might be the one that you might have to get used to the most, the not equals to sign like that. Oops. So let's set up some values. I'm going to do x equals 10. I'm going to do y equals 10 as well, but I'll do 10.0. So it's a float type like this. This is int type. decimal like that. And now let's see what happens when we use these symbols. And I'm just going to put it inside the print statement itself. Let's say X. So I'm basically asking, is X equal to Y? And print it out. And we could see I get true back. I'm going to get true and false back with these. And let's see what's actually happening. So I'm going to see what type is that true? What type of object is it? It's a bool type. That's that last type that we talked about. True, false values, basically. So that's its own special type of value. I can check, is X not equal to Y? That's obviously going to come out as false because 10 is equal to 10. If I change this, we change that to 11. So we can check something like this. 10 is not greater than 11. But if we switch it, then we see 10 is less than 11. So we get true in this case, but false above it. So that is the Boolean type, the last special type of data that we have. Only two possible values, true and false. We can see above how we can get those values, but how can we make an object by just giving it a Boolean value? Kind of same thing as always. To say name is equal to, and then in this case, we just call it true like this. We don't need to put it in quotes. In fact, if we do, it becomes a string type object and not a bool type. We can see it's kind of highlighted blue, so it's a special type. So that's true. Something else equal to false. So you can see no quotations. And the only thing you have to keep in mind is they must be capitalized. So this is not the same as this. You can see Python is not quite good enough to recognize that as a bool type. They need to be capitalized. So the reason that we have bool types is to be able to get to this huge step in any type of coding, which is to be able to say, doing specific things based on conditions. You know, if X, then Y, else Z. Meaning if X is true, we need to be able to check some condition, which we now know how to do. Do Y, else Z. So we'll now write code. And depending on some conditions, some code will execute and some code will just not pay attention to based on the condition that we give things. So we have three types of kind of conditional checks. If, what's called elif, which as we said in the beginning of the class, is just an abbreviation of else if. And then we also have else at the end. And going into this, they mean the same thing they do in English. If X, then Y, else Z, you know, basic logic like that. So let's take a quick look at how to do it in code. And we'll see we can kind of build up to doing actually now that we have so many steps. So let me set up some data objects and then we'll take a look at how to use if. So let's make an object called cost. And then we'll say my money is equal to 22.50. So I'm coding some type of problem when I have some amount of money in my wallet. And I want to be able to see if I can buy things, if I can buy something that costs $9.99. So to use an if statement, we need to follow an if statement by some condition, and then we need to do some indented block of code. So what's happening is, take a look at this example. If X is greater than Y, then we execute all the code that's indented beneath it. And then once we kind of outdent again, we've kind of left the if clause. But if X is not greater than Y, we actually just skip this step completely and jump to this step. So we can now skip steps and kind of selectively run code based on conditions. So we have these objects, and now let's set up a little if clause. So I can say, actually, let's just check what this is equal to. So basically, in these if clauses, I want to check if I have enough money to buy this cost. So let's see. It's true that I have enough money. I have $22.50. It costs $9.99. This is going to give me a bool type. And we need bool types to be the condition. What we put in this place needs to evaluate to true, false like this. So we'll use these conditional symbols like this. So let's say if my money is greater than or equal to cost, jump to a new line. We can see Python automatically indents the line because it knows that I should be indented. We'll put a little message. We'll say, you can buy this. And then when we want to leave the if clause, we can just outdent again. So we just backspace. And then I'll just put a little message at the end that says, have a nice day. So if I click play on this, we can see I get this print. I get this one as well because my money is greater than or equal to cost. So I go inside of it and then I get this one. If I change this to 250 and then click play again, we can see I do this because all statements in Python execute just kind of at this base level. But then when I get to this if statement, this evaluates to false at this point. So now I skip anything kind of inside this code block, what's indented. So I don't get this, and then I just get this one again because I've outdented, and I'm just kind of at that basic level of just execute everything at this point. If we want to do a second if clause, we could do something like if my money is greater than or equal to cost times 2. Let me say, wow, you can buy this twice. When I click play, we can see I'm still skipping both of these because these both evaluate to false. But now if I jog my money back up, we can see I pass both if clauses. So I go inside this one, then I get to the second one. I also pass this test. So I go inside. And then as always, I get to this final statement, which because it isn't indented to that if clause, I just always execute it like that. So pretty simple to use these. We just need some kind of conditional statement that's going to evaluate to true, false to see if we do something, if not, we do something. So pretty easy. But even at this point, we can see not an issue, but a limitation with just using if. We can see I have both of these things printing, but what if I only want this one to print? I don't want to say you can buy this and you can buy this twice. I just want to be able to say this and not that. So how could we set that up? Well, the second set of the series is elif. Elif means else if. They must follow an initial if statement, and they have to be in a chain. So like if, elif, elif, elif. You can have as many chains as possible, as you want, I should say.
I'm sorry for interrupting you, Matthew, again. Right at this point, what is displayed on your screen, you see that square parenthesis towards the end, and where in comment you are saying elif statement. How are you creating or introducing that gray section? Is there a way, or we can do it too?
You mean like this special like styling? These look like boxes?
No. Right after that, where that empty this.
Oh, this?
No, beneath that, the green with comment. Yeah, right. That one. You have given us those, or the Colab we open. I think this is a question for the editor, I believe, about Colab, which is very new to me. So can we introduce that? Can we get a new one? Or it is like you gave us that?
Like get a new cell?
Yeah, correct.
Yep, that's what we said. So if you click on any box, and then you go up to the top, you see these buttons show up.
Right.
So if you just click on add code, then you get a whole new box like that. So you can add as many as you want.
Oh, okay.
Yep, so you can add new notes as you want. You can add code. You can add a little text cell like that. And then if you look on this side, you can kind of delete them using the trash can as well.
Okay,
Yep.
okay, okay,
Yep.
thank you.
Yeah. Okay, so now we looked at if, but we saw that slight limitation. So let's look at else if now. So I'm actually going to copy this chunk of code to see what happens if I just change one small thing in it. I'm actually going to put this ahead of the second one. So I'm going to say, check if I can buy 2 of them, and then check if I can buy 1 of them. If I click play now, I still get both of them to come out. But if I change this one to that else, because we said this is mutually exclusive from this one, when I click play, I only get this one. And that's because even though this passes the test, it is true. Else if means I only run this code if anything above me failed and I am true. So since I went into my if statement, elif says, even though I passed my test, else if logically means since you already did this, I'm gonna skip this elif and any elifs after that in the chain. So it's mutually exclusive like that. And then finally, else, kind of easy like if, it kind of makes sense. Else has to follow an if statement. So you could have like an if and then an else. It could also follow in an if elif chain. So you could have like if elif else. You could have if elif else, like that. And like elif, so mutually exclusive from the conditional statements above them. In fact, they're almost completely like elifs with one exception. So let's copy this again. Paste this in. And the special thing about else's is they don't have any condition. We don't check if anything is true or false. We can just say else. We'll add a little message. And then let's change how much money we have. And then we can see we get the message that we have below the else line. And so what's happening is Python runs top to bottom. It's saying, okay, I know what cost is. I'm making these objects. And then it's going to this section of checks. So I'm going to say, is my money greater than or equal to cost times 2? Well, that comes out to be false, so I skip this one. Then I say else if my money is greater than cost. Well, that's also false, so I'm going to skip this. And then I just say else. I don't have to check anything. As long as I failed all the if elifs above it, I just always run this down below. So this has no condition. Always runs if ifs elifs above failed. So that's the 3 of them. You can see it's kind of easy to chain them up. The only thing that might trip you up is when do you need if and elif, and when do you maybe need just 2 ifs back to back? Because we can, as we saw in the beginning, this is not mutually exclusive to this. So kind of independent. We check this and then do it if we pass, and then we check this and do it if we pass. But down this way with elif. Oops.
So Matthew, right
Yes.
there in elif example, before you introduce else only, when the if condition was true, so it did not execute anything under elif because the if portion was true, right? So
Yeah, exactly.
had the if condition been false, then what would have happened? That elif would have been executed, right?
Yep. So if we change this, we'll say we have 50 cents. Actually, let's say, we'll say 10.50. So we can say, we check it top to bottom. So do I have twice the cost? Well, I don't, so I don't execute this. And then I say, else if, do I have at least the cost? And then I do execute that because I passed that test. But as we saw, if this was something like this, since I passed this test, I just kind of skip this one because I already passed the if test and it's mutually exclusive. In an if, elif, else chain, you can only execute one of them because it's all mutually exclusive like that.
Right, right. Okay, okay.
Yep.
Thanks for showing.
Uh-huh.
Thanks.
Okay. We'll do a couple last things, and then we might have to finish up the last couple steps of this and the practice problems. I just have 2 pages left in my notes, but I don't think we'll be able to squeeze it in today. But we'll just go up until the end of the class, and then we'll wrap up next class. So adding into the toolkit, which we can use a lot with the conditional checks we just did, we have some new key phrases and not, or like this. And if we recall what we saw in the beginning of the class, we can see and is one of these. We can see this guy. We can see not is in this. And we can also see we've seen a couple of these. So we've seen false. We've seen true if that's in this. We've seen elif, else, if we've seen. So just within one little basic class, we have quite a couple tools of basically all the tools in Python. But let's look at what these tools mean. So these can be used to connect multiple conditional clauses, kind of what like you would expect. So if we connect 2 things with and, that logically means all those statements must be true. If I say, if something and something, then why, then I need to pass both of those to do it. And kind of the opposite like this. I only need one to pass if I have this one linking. And then not, it just basically negates something, and we'll take a look at that. So let's set up a quick last example. So let me say my grade is going to be equal to 100. And then let's do a couple different objects. Let's say name is equal to Jack. And then let's say last name is Jones, just so we have some data to test with. And then let's see, how could we do things without the things above? And then how can we use these things to kind of neaten up the code? So if I had something like this, I want to see, only print out something if someone's name is Jack and last name Jones. So right now I might have to do something like this. So if I do this, you can see I'm checking if name is equal to Jack. And then I'm actually nesting an if inside of a second if. So I'm kind of stacking them up. And then I do a second check to see if last name is Jones. And then only if that's the case do I get hi Jack Jones. If I change this to Smith, we can see nothing passes because I failed this second check. So I didn't run this. And then I didn't have any code following that. So that's why that failed. But this gets kind of ugly. I'm kind of stacking this out and nesting ifs, and it can get a little wobbly on the page. So how can we do this neatly? Well, we could do something like this. If name is equal to Jack and name is equal to Jones.
Yeah, you said and, so that's why it won't happen, right?
Oh no, I just wasn't clicking it. So let's see. So I'm saying if name is equal to Jack, that's true. And name is equal to Jones, that's also true. I passed all of my tests, so then I get inside and get that high.
How name equal to Jones is true? Name is not Jones. Surname is Jones, right?
Huh? I don't know.
Yes, you clearly saying that
Oh,
surname is Jones, right?
Surname is Jones.
thank you. Thank you.
Surname, not
Yeah.
name, yeah.
Okay. So we can see we can just tidy up the code by using these linking things instead of doing something like this when we kind of have to nest things inside of things like that. Let's take a look at the other type of one. And we'll use that grade that we put above. So we can say something like, so we can say like, if grade is above 98, we can put a little message, see the teach because we want to give you a good job. But if grade is less than 65, we'll say the same thing, but in this case, we mean you might need some help, so see the teach like that. We get nothing because I have a 95. If I jump up to 100, I get it. And if I jump down to, let's say 10, I get it as well from this case. But how can we combine these? Well, instead we can do if grade is above 98, and then we'll use a new linking phrase and say grade is less than 65. And now I get it both ways like this. And we can see two things happening, two conveniences. One, I just have less lines of code, and that's always useful. I only have to write this statement once. I kind of have copied myself this way. And it's kind of a principle of coding to only write things as many times as you need to. If you can write something only once, then it's best to only write it once, because if you have a long program with hundreds of lines and you had to make one small change, but you had written that line a couple times, maybe a dozen times, you would have to make a dozen changes and find all of them and hope not to miss any of them. But if you use the principle like this, when you try to only write a single thing once, if it's the same line of code, you only have to go back and change it a single time like this. So it saves on like copy editing, making mistakes, just how much time it takes you to type it and things like that. So this is the preferred way of typing code. Okay. So we'll go ahead and call the class now. Next time, we'll do the last big tool in Python, loops. And then we'll do a couple big problems to kind of combine this all and see how to make something, how to make a little bit of code that actually seems useful, and it's not all these small examples. So if you have any questions, I'm free to hang around, but I know it's the end of the class, so if you want, go ahead and sign off. I'll see you next time. I'll post the video on YouTube if you want to watch a section of it again or something. I'll send out the link once it's uploaded. But if not, I'll see you next Wednesday.
Same time, 2 p.m., right?
Yep.
Same time. Thank you.
Thank you, Matt.
I have no more questions. Really enjoyed the class.
Thank you. Yeah.
Me too.
Thank
Okay, yep. So next week,
Bye,
we'll,
everyone.
we'll finish up next week. And if you have any questions, like if you want to look at it at home and you get confused by something we did, you can ask me at the beginning of next class as well. We'll take questions up at the top and then finish off and then go on to week 2 stuff.
Matthew, one last question. Is it possible to shoot you an email just in case? I don't need to, but just asking.
Oh yeah, absolutely. You have my email. I sent you the Zoom link. So if you get any questions when you go back and look at this, I'm happy to respond to emails about this.
Okay, thank you.
Yep.
You're a great teacher. Bye now.
Yep. Have a good day.